tutorial, which is a continuation of the morning session. The topic is asymmetric synthesis in drug design, auxiliaries and reactions, part 2. We look forward to more in-depth exploration of this essential topic in modern synthetic chemistry. Let's begin the session.
A very good afternoon. Okay. So in our morning session, we have studied about the asymmetric aldol reaction. Okay. So by using one auxiliary, we planned one enantioselective product. Okay. So now we have to move the last part of this asymmetric synthesis in drug designing. So again I am coming back to the reaction which we are talking in the morning regarding the asymmetric aldol reaction. So if seeing on this picture, just a one question has been asked to you, that how will you plan any one enantiomer out of the 4? Give answer in just 2 sentences. Without any mechanistic details, then how you are going to answer that? Without checking the mechanism or the detailed reaction steps, just on the basis of the theoretical concept which we discuss, can you answer for that? Okay. And the second question, if it is associated with it, out of these 4, how you classified them? You convert it into 2 groups. One is your syn enantiomer and the other is your anti enantiomers. But within this you can differentiate in syn both OH and R on the same side, or it can be on the opposite side. So now you have to think the answer of the question which I asked, and the answer is very simple in 2 lines. First you have to say that in this reaction which is on your screen, if you understand the 2 to 3 keywords of asymmetric synthesis, you can easily going to attempt or answer this in interview. The first question that you have to say, that in the selection of E and Z enolate will lead to either of the group. Okay. So if you have a Z enolate, what type of enantiomer you are going to get? Syn enantiomer. What is Z? The groups are on the same side. What is E? The groups are on the different side, opposite side. So just by looking this picture, I said you don't know any mechanism. Okay, you don't know any steps, but if you listen 4 to 5 lectures very carefully, you have to just give the keywords, that how you are going to attain any one in majority. So you can say in first line, by appropriate selection of either E enolate or Z enolate, we can rule out the 50% of the product. For example, if you choose or plan or introduce Z enolate in your reaction, you will exclude anti enantiomer directly, because Z enolate is always going to give you syn. So if you choose E enolate, then you 50% that syn enantiomer will be out of this. So by just choosing appropriate enolate, your 4 products are now possibly convert into only 2 product. Now come to only 2 product. For example, syn enantiomers. How you are differentiating between 1 and 2? In 1, OH and R on the above the plane, and in 2, OH and R on the below the plane. So if you want to attain number 1 molecule, you have to block the other face. If you have to attain number 2 molecule, you have to block the upper one. So this is the 2-liner answer if you know about the asymmetric synthesis. That in any chemical reaction they can ask and they can give you this example and just give the answer if you know about asymmetry. They are not asking about any mechanism. Just looking into this, you can directly tell that how you are going to get one particular type of product. Okay. Now if you see this reaction, okay, if I go to this reaction, can you identify how the substrates are going to react to give the final product? In your first product, you have ACOH. Which functionality of this substrate is going to participate? कौन सी करेगी? प्रोकायरल कार्बन किसके पास है? कार्बोनाइल ग्रुप के पास. तो you have a 2 atom, carbon and oxygen. Now go to the part of your enolate. You have a carbon-carbon double bond, oxygen negative and metal positive. Now when these substrate are coming in this space, carbonyl के 2 atom, enolate के 4 atoms. enolate के क्या हो गए? कार्बन-कार्बन डबल बॉन्ड, ऑक्सीजन नेगेटिव और मेटल पॉजिटिव. 4 एटम्स आपके इनोलेट के, 2 एटम्स आपके कार्बोनाइल के, तो टोटल कितने बनते हैं? 6. सो व्हेन 6 ग्रुप्स आर और एटम्स आर कमिंग टुगेदर इन 3 dimension form, what will be the appropriate conformation they want to get? 6 मेंबर में आपकी कौन सी बेस्ट कॉन्फ़िगरेशन आपने देखी है? साइक्लोहेक्सेन की कॉन्फ़िगरेशन पता है आपको? विच वन इज चेयर, बोट, ट्विस्ट एंड हाफ चेयर. तो उसमें होता क्या है? साइक्लोहेक्सेन इज 6 कार्बन. ओके, सो यू आर सेइंग दैट 6 कार्बन विल बी बेस्ट स्टेबल इन चेयर फॉर्म. उसमें या तो ग्रुप एक्सियल पे होगा या ग्रुप इक्विटोरियल पे होगा. सो जस्ट इमेजिन आ साइक्लोहेक्सेन मॉलिक्यूल. आप इसको आपस में जब रिएक्ट कर रहे हो, हाउ दे आर गोइंग टू लाइन इन अ स्पेस. नाउ सी इन दिस पिक्चर. फर्स्ट पिक्चर you have carbon oxygen double bond. Forget about A and H. They are either going to take the axial position or equatorial. Now in the enolate form, carbon carbon double bond, oxygen negative and metal. Now how these 6 are coming together in a chair conformation. Now if you see, you have a E enolate. What is the meaning of E? Your R and O negative M, they should be on the opposite side. Now see the picture which I have shown in red color. Carbon oxygen bond is in red color, carbon R bond is in red color. If you have a E enolate, check oxygen and R are opposite to each other. Now if you go to the Z enolate, what is Z enolate? R and O negative M on the same side. So you see carbon oxygen and carbon R, they are group on the same side. So the question comes, that with the stereochemistry at carbon 2 and carbon 3, you are able to get preferably either S or either E molecule. So if you are planning a such type of reaction, appropriate enolate is going to give you this. तो अब आप देखो 100% में से आपने 50% तो पॉसिबिलिटी को रिड्यूस कर दिया, या कह सकते हैं 50% पॉसिबिलिटी आपने सेलेक्ट कर ली. ओके, सो फर्स्ट इज द रिलेटिव स्टीरियोकेमिस्ट्री एट कार्बन 2 एंड कार्बन 3. अब मुझे देखो कि आपने 50% ई इनोलेट प्रेफर एंटी एल्डोल प्रोडक्ट, जेड इनोलेट प्रेफर सिन एल्डोल प्रोडक्ट. अब आगे की कहानी 50-50 तो कर लिया आपने, आइदर सिन आएगा और आइदर एंटी आएगा. अब सिन में भी आपके पास 2 है, एंटी में भी 2 है, उसको कैसे सेलेक्ट किया जाए. अब मुझे बताओ फर्स्ट जनरेशन में क्या किया. नाउ आई वांट आंसर फ्रॉम द ऑडियंस. इन फर्स्ट जनरेशन हाउ you selectively, how selectivity is done in first generation? You place something on substrate so that the incoming group can be selectively come. Now in this case you have a carbonyl hydrogen and R group, or in your first picture it is ACOH. अब A जो है अगर आप उसको सेलेक्टिवली प्लेस कर दो तो जो सिन में आपके 2 है वो 1 बन सकता है. कैसे? अब आप इस पिक्चर को ध्यान से देखो. मैंने जो A है, जो आपकी ये पहले वाली पिक्चर में A है, कैन यू सी A? ये जो A है उसको मैंने सेलेक्टिवली इंट्रोड्यूस किया. क्या सेलेक्टिविटी इंट्रोड्यूस की उसमें? हाइड्रोजन इज अबव द प्लेन, मिथाइल इज, और जो आगे ओ बेंजाइल ग्रुप लगा रखा है वो मैग्नीशियम के साथ चिलेशन भी कर रहा है. नाउ योर इनोलेट इज कमिंग. अब बताओ आपने इनोलेट को कौन सी प्रेफरेंस साइड दी है? द कार्बन नेगेटिव शुड कम टू द कार्बोनाइल कार्बन फ्रॉम द साइड ऑफ हाइड्रोजन और फ्रॉम द साइड ऑफ मिथाइल? From the side of hydrogen, that it is coming from the upper face. Okay, so now from 4 to you move only 2, from 2 to you move only 1. So your enantio selectivity will be the best one in this case. So in any example this is one choice, that you place chirality in your aldehyde. Now if you place chirality on enolate, then you can also select one. So for that you have to prepare one auxiliary, that is your Evans auxiliary. अब आपने इस फाइनल स्ट्रक्चर में देखो, एक तो आपने इनोलेट लिया, इनोलेट कौन सा ले लिया? Z. क्लियर? उसके बाद उसके ऊपर एक कायरल ग्रुप भी फिक्स किया हुआ है. Now can you see 5 membered cyclic ring and there is one group, isopropyl group आपको नजर आ रहा है उसमें? That isopropyl group is lower the plane. Okay, so when you are reacting it, okay, now the reaction in such way that if that isopropyl group is going to create a steric hindrance from the lower phase, the product will be from the upper phase. So in this case I will move to the reaction this. अब आपको चॉइस दे दी, काइंडली सिंथेसाइज नंबर 1 selectively. तो क्या आप करना चाहोगे? You have to selectively synthesize sin enantiomer 1. Okay, so वही 2 लाइन का क्वेश्चन. सबसे पहला क्या करोगे? इनोलेट वो चूज करोगे जो क्या होगा, Z होगा या E होगा? Z, क्योंकि Z इनोलेट ही कौन सा देगा, सिन, E इनोलेट कौन सा देगा, एंटी. So first question, choose Z enolate. Once you choose Z enolate, you will get syn product. अब next step क्या करोगे, either your aldehyde or either your enolate place a auxiliary which will block the lower phase. चाहे वो आप एल्डिहाइड पे लगा लो. तो जब इस स्टेप में हमने दिखाया ऑक्सिलरी कहां प्लेस की हुई है, एल्डिहाइड पे. ओके, जो मिथाइल ग्रुप है उसकी साइड से ऊपर से ग्रुप आ रहे हैं, आइदर आप ऑक्सिलरी प्लेस कर दो इनोलेट पे. पर ऑक्सिलरी कैसे प्लेट करनी है, लोअर फेस पे आपने कौन सा ग्रुप लगा रखा है, आइसो प्रोपाइल ग्रुप. सो इन दिस वे यू आर able to get only one type of product. So अब बताओ, if you are going to ask asymmetric aldol reaction with enolates, will you able to explain it without even seeing the reaction, without even seeing the mechanism? Okay, this is the general step. Everybody can ask you if you are doing a synthetic work. See, what we are doing in the laboratory, if you are talking about, okay, what we are doing in the laboratory, it is a conventional works. Okay, when you move to the industry, they are making the products which are directly used in the market. Okay, so in that case, whatever the chiral product, if you are in the pharma industry, they are making the drugs molecules where chirality is already associated, because the human biological system, the enzymes, they are stereospecific in nature. They can distinguish the both enantiomers. So that's why they require the pure compound. Okay. So this is a very simple method in 2 line, that the all the 4 products are available. Which type of enantiomers you want to prepare, you can simply tell them by 2-step reaction, that choose appropriate enolate. After choosing the appropriate enolate, either block the phase in your aldehyde, either block the phase in your enolate, and you will get your final product. Okay. So there is another example, that is asymmetric alkylation. Now can you see in your substrate where the alpha carbon is present with respect to carbonyl group? Can you see in your substrate? Okay. So at that position you want to introduce the alkyl group. What is that alkyl group? That is methyl. So in this reaction, if you have to see product, here you have to introduce the methyl group. For that you are using the methyl chloride as a reagent. Solvent जो use किया है, that is toluene, phenyl methyl, and then aqueous sodium hydroxide. इसमें आपने एक catalyst use किया है, synconine. Okay. Now can you see what is important in synconine? अब इतने बड़े बड़े स्ट्रक्चर्स को आप अगर भूल के एसिमेट्रिक सिंथेसिस और फेस की बात करो, और सारी एसिमेट्रिक सिंथेसिस में एक ही बात रहेगी, जहां आपके पास 2 doors are available, close one, let it be from only one side. So अब आप अपने प्रोडक्ट में देखिए मिथाइल किस साइड से ऐड हुआ है, अबव द प्लेन. सबको विजुलाइज हो रहा है. ओके. कैटलिस्ट में देखिए कायरलिटी कहां है, हाइड्रोजन एंड OH. विच वन इज on upper side, hydrogen. Okay. So this alkylation of carbonyl is done with the help of this catalyst. ये catalyst कैसे work करेगा? This catalyst have nitrogen positive charge. Okay. It is reacting with aqueous sodium hydroxide, moving into the organic, वो पढ़ा है, that phase transfer catalyst. Now this catalyst is moving into the organic phase. Once it is moved into the organic phase, वहाँ पे solvent क्या available है? Toluene. Now this catalyst has to direct the reaction. कौन सी generation होगी ये? It is generation 1, 2, 3 or 4? 4. 1 is substrate, 2 is auxiliary, 3 is reagent, 4 is catalyst. Now your catalyst is directing the incoming methyl group to attack the substrate from which phase? From the upper phase, because the chiral unit present in catalyst, you can see hydrogen and OH. So if you see the combination methyl chloride, the methyl is coming, it will come from the side of hydrogen. If forget about this number 2 syncodine, then you have a carbonyl which is planar in nature. Bring the methyl, it can come from up or it can come from below. So that enantioselectivity is done with the help of catalyst. And what is the plus point of catalyst? It can be recovered and reused. So this is the example asymmetric alkylation. Okay. Now this is a very important reaction we have studied, that is the sharpless epoxidation or asymmetric epoxidation. Now what is the substrate? If I say it is like a allyl alcohol, if you see substrate, you have a carbon-carbon double bond and CH2OH. Carbon-carbon double bond and one carbon, you call it as a allyl unit, and then you have a functional group OH. So that is allyl alcohol. Okay. R1, R2, R3, they are the different group. अब आपने epoxidation करनी है. What is epoxidation? You have to attach the oxygen across carbon-carbon double bond, but you have one query, carbon-carbon double bond is a planar. अब oxygen कैसे जाए? Normal reaction करोगे, it can above the plane and below the plane, but you want to achieve the 100% enantioselectivity. So what you done? You try to put a one phase with lot of steric hindrance with such a bulky group, so that this reaction can occur only from the one side. Now if you see the number 59, what is this 59? This is just the complexation of the reagent which you are using. Which reagent you are using? Titanium tetra isopropoxide plus diethyl tartrate. Diethyl tartrate, you can take Rn, Rr and SS. What is the difference between Rn and SS? This is just the arrangement in the space, whether it has a R configuration with particular carbon or whether it is as a S configuration. So these two are only differentiate with respect to the planes. Okay. So titanium tetra isopropoxide and tartrate, diethyl tartrate, they first come together, make a complex. Okay. Now can you see if we mark it as a 59? Now if you see 59, such a big structure with the substituents like titanium isopropoxide, CO2 ethyl group. So once this is there, now imagine here you can see that this is the sheet and like this. So titanium tetra isopropoxide and diethyl tartrate, they are clubbed together to block one phase. Now what happened? What is your substrate? Allyl alcohol, it is coming to that complex. Okay. Who is going to give oxygen to the allyl alcohol? You use tertiary butyl hydroperoxide. Peroxide means it has an extra oxygen, so it is going to deliver the oxygen. आपने पहले टाइटेनियम और डाइथाइल टार्ट्रेट से एक कॉम्प्लेक्स बनाया, अब उस कॉम्प्लेक्स के ऊपर आप अपने दोनों सबस्ट्रेट को लेकर आ रहे हो. वन सबस्ट्रेट इज योर एलाइल अल्कोहल. इस एलाइल अल्कोहल को ऑक्सीजन देने वाला रिएजेंट क्या है? टर्शरी ब्यूटाइल हाइड्रो peroxide. अब आप इसको ध्यान से देखो that these R groups, they are present below the plane. So your substrate are coming from the above side. Now you can see titanium O alyl group. तो यहां से आपका आ गया tertiary butyl hydro peroxide. Now can you see these red lines? This delivery of oxygen is occurring from the same phase. So in this case you are going to get only one particular type of epoxide. Now if you choose the another tartrate, then alyl alcohol and tertiary hydroperoxide is going to hook from the bottom side, then the oxygen is delivered to the substrate and your reaction is going to occur. So in this reaction the possibility is what? In the complexation stage, carefully check the positioning of the substrate alcohol and the tertiary butyl hydroperoxide, which is going to deliver oxygen through one phase. Check complex 59 where tartrate and titanium form the initial complex. So that is asymmetric epoxidation, where selectively, now in a simple way, without seeing this 59, a simple question asks what is the difference between epoxidation and asymmetric epoxidation. It is a two-liner question. Forget about 59. You don't know titanium isopropoxide, you don't know diethyl tartrate. What you can say, sir, in carbon-carbon double bond, it is a planar one. If we are going to add a reagent, oxygen can come from the above side, it can deliver from the below side. But what is in sharpless? Sharpless efficiently try to block either the above and below by introducing a complex. What is that complex? He used titanium isopropoxide for the bigger group, and he used for selecting of these two phase either by RR diethyl tartrate or by SS diethyl tartrate. So if you block any of the phase, your substrate are definitely going to go from the opposite side. So if your both substrate are in opposite side, allyl alcohol and your tertiary butyl, you can get only one type of epoxide. So that is the enantiomer selectivity is 100% in this case. Only because the closing blocking of one phase by such a 59 complex. Okay, that is the important part of asymmetric alkylation. And I have shown you one very important compound. If you see, that is your L-DOPA. This is a drug which is used for the anti-Parkinson disease. Okay, can you see in this chiral center what you required? One NH2 group, one COH group, and the other side is your hydrogen and aromatic ring substituted by 2OH. So the industry which is making this drug, okay, they require this drug in pure enantioselective way. What is the difference? Why pure enantioselective way? Anti-Parkinson disease में क्या है? The drug has to reach brain. So brain has a barrier, it has a membrane, it cannot allow every molecule to pass through it. Okay, so out of the two enantiomer, it will allow only the delivery of one enantiomer to that. So that's why its name is L-DOPA, the only one enantiomer. How we differentiate between enantiomer, L or D? So it will only allow one to pass to the brain barrier. Okay, so in this case you have to synthesize this molecule. आपने